Good morning, engineering students. Today is Tuesday, March 31st. We are continuing in our reverse engineering unit, and you should have gotten an email by now indicating that Thursday and Friday this week you don't have school. So today is your lesson for Tuesday and Wednesday, and then you're done with me for the week. And what's going to happen is you'll have Thursday and Friday off. You'll have a week off then because it's spring break. And then after spring break, the email that you got should have indicated that it's going to be an online type of school where you'll go to class for like 3.5 hours, Monday, Tuesday, Wednesday, Thursday, and then Friday you won't go to class, and it's going to be more structured. I like it. I think it's a good idea. It's not going to start until after spring break. And then right now, we are planned to be off campus until May 4th. We may go longer. We're thinking we might go longer, which is why we're trying to get this very organized schedule up and running. All right, so we're in the reverse engineering unit. And this lesson I thought we wouldn't be able to do because we don't have our little cars, but it turns out most of this lesson is researching about these materials online and writing. So I think we can do this lesson. So obviously we're talking about these little Automata Blocks cars. And in this unit, you've done some of science. We're kind of going over the stages of engineering, right? The stages of engineering. And you've had a couple of assignments on visual analysis. We talked about objects you loved and hated, and then you grabbed some items at home and talked about their visual elements. I had you choose an actual product and talk about how it functions without taking it apart. And then here, we're going to kind of do something similar to that, but we're going to focus on what it was made out of, basically. That's kind of what this assignment is, which we're going to be looking stuff up online. All right, so let's go ahead and talk about engineering, and then I'll talk about the assignment too in this lesson. All right, so why is reverse engineering used? It can be for a variety of reasons. Sometimes it's an old product with no existing documentation, and the company has to reverse engineer their own product. That's probably not too common. Oftentimes, this is an example. Let's say that you're a company that would like to make a toy car. Well, then it would make a lot of sense to take apart another company's toy car to understand why it was made a particular way, learning from someone else. And sometimes this companies take apart their own products to study what they did in order to reanalyze them and remake them. Because we always want to try to reduce costs in engineering. It's a big one. And then eliminate failures. As well as make it work better in general, improving reliability. We care a lot about those things. But if we can make the same toy car for half as much money, or the same toy car that never breaks, we're going to try to do it. So let's check out this assignment. Uh, so the idea is that the car is made of different materials that were very intentional materials. And this is going to be kind of fun because the idea behind this lesson is that you guys are going to kind of just take your best guess, and then I am going to host a discussion of this on our like first day of class, maybe our second day of class, and so you guys will talk to each other and to me about the different materials you think why they chose them. So let's get into this assignment. So basically, we're talking about those automatic blocks cars. And you're going to either justify the choice of the material, meaning you're going to talk about why you think polycarbonate was a good choice for the windshield, or you're going to talk about why you may think an alternative material could have been better, like glass. Glass could be a windshield. Auto glass is used to make windshields. But they use polycarb instead of an acrylic or a glass. So you're going to approach from these four things, and I'm going to go over them in the lesson on the next few slides. And so I'll talk more about those on the next slide. So we'll talk about the assignment right now. All right, so the parts you're going to go over is the windshield. You're going to go over here's the windshield by the way. The tire, which is made out of rubber. The body, that's made out of wood. The connector, which is an ABS plastic, and the axle. Oh, I'm sorry, it's cut off by the picture. It's car axle. If you just Google axle and Automata Blocks, you'll find it for sure. These slides are also hosted online, so you can just click it and take a look at what's right there. It's a little axle. I gotta remember that. All right, let's talk about what these are, right? Because it's hard to do the assignment without at least talking about these a little bit. So let's move forward. All right, so workability. Workability is kind of how much you can work with a material before it kind of fractures and cracks. And in this context, workability is just how easy is it to work with the material. You can do things with plastic that you cannot do with wood. You can melt plastic and shoot it into an injection mold. You cannot melt wood and shoot it into an injection mold. You can only carve wood. Wood is not a very easy material to work with if you think about it. Not a lot of stuff is made out of wood. When's the last time you bought a laptop that was made out of wood, or really anything with tech in it that's made out of wood? Wood is usually like expensive old furniture. So the fact that they used wood is very interesting, and I think we will definitely talk about after spring break. Um, Next is durability. I think most of you are pretty familiar with durability because we care about the durability of our technology a lot of the time. So our toy car, what were the durability of the different material choices and why? I think it's a pretty simple word, durability. It's sturdiness, solidity, soundness, wholeness. You know, basically how difficult it is for the material to break. Next, they talked about transparency. So obviously, some materials are transparent, some are opaque. We want to keep pushing that vocabulary. Opaque means the opposite of transparent. And so some obvious things there, but still an important thing to analyze. Are there other transparent materials? Like I threw out glass, polycarbonate, acrylic. What other translucent materials are there? How else could they have made the windshield? Interesting. Um, Friction. All right, this is a slide from physics. I'm not expecting you to do physics. However, coefficient of static friction and coefficient of kinetic friction, you're going to bump into a lot. And I figured you're not going to know what that means unless I teach you a little bit of physics. All right, I'll give you the very simple version. Basically, it's a property that you can measure. And so if you look up online any material like rubber and you look up what its coefficient of static and kinetic friction, you're going to get a number. Coefficients, they're going to be from somewhere between 0 and 1. And then basically the way physics works is the weight of the object multiplied by the coefficient gives you the force. So this is and N just means weight in newtons. So N is weight. Weight. And so that's the idea. So basically, the bigger the number, the more difficult it is to push it, and the better it's going to be for friction. So some objects need to have high friction like the tires, some low friction like the axles, but there are other material choices they could have used for those two things. So maybe there's a different material other than rubber they could have used for the tires. I don't know, but you're going to be looking up coefficient of static friction, looking for something similar or maybe better or maybe cheaper than rubber. And then coefficient of kinetic friction. Kinetic friction is when things are sliding. And so when things are rubbing but still moving. Static is when they don't move. And then kinetic is when they are moving. And so static is always slightly higher than kinetic. So make sure that you don't, this is why I wanted to teach you the physics. You need to make sure that you're not comparing the coefficient of kinetic friction of like rubber to the coefficient of static friction of like wood. You need to do kinetic and kinetic or static and static, or it's not a fair comparison because every material has a static and a kinetic friction. And like I said, you actually can calculate the friction by just multiplying that coefficient times the weight. So for example, if you weighed 100 pounds and you had this coefficient right here, then the force of friction would be 40 pounds. If you weighed 100 pounds and someone tried to push you, the force of friction would be 40 pounds because of the coefficients multiplied by weight. So that's the activity. Basically, it's okay to don't worry about necessarily being right or wrong. Just make sure you come up with answers that you've researched, as in you're looking up these materials. We're gonna do like a discussion. So it might turn out that you decide that you're gonna use gold for the tires, and maybe you misunderstood the table and you thought that was really like a good friction material, but it's not. That's okay as long as you have all that and you bring it to the discussion we're going to have, and then we can work through it and try to understand why you came to that conclusion and help you to understand why it was a good or maybe a bad conclusion to come to. All right, I'll see you guys all in class virtually after spring break. So make sure you get technology and internet hooked up. If you don't, Office has ways of helping you. See you guys then.